8, 10. Yeah. So how do we solve problems where the equation is given? It really should say, how do we solve problems where the equation is given and is nasty? Just completely nasty and not a whole lot of fun. And the reason it is nasty and not a whole lot of fun is because it's a basic level math problem where they're giving you everything but one variable. So when you start to look at these and go, that looks so tough, ask yourself, if I gave you, y plus x equals 7 and said solve for y when x is 2, well, you'd be like, well, that's pretty easy. I can solve for y when x is 2 because I can subtract 2 and get y equals 5. Now, that's a very simplified version of what we're about to do, but it's the same idea. They're going to give us every single number in here but one. Okay, either they're going to give us the number for m, p, and r and make us find n, or more than likely p, r, and n, and they're going to make us find something. So we are probably going to have to work backwards and do a little bit of work, but it's algebra, but algebra with some nastier decimals, but the idea is the same. You have one variable, get it alone so that you can solve, which is not a lot of fun. So let's read the first question. All right. Monthly mortgage payments can be found using the formula below, and it looks like fun. There it is. M is the monthly payment, P is the amount, R is the rate, N is the number of payments. So we have the Banks family. Kind of funny that they're called the Banks family, but whatever. The Banks family would like to borrow $120,000 to purchase a home. They are qualified for an interest rate of 4.8%. So we have our rate. Start off with that, right? 0.048. We got that by dividing 4.8 by 100. Then we have our P, which is the amount we would like to borrow, $120,000, amount borrowed. So this is P, okay? $120,000. And there we're going to keep on reading. Of course, I can't erase the y equals 5, but whatever. So the bank family decides they can afford a payment of $720. Well, the monthly payment, I guess I'll put that in a different color so it stands out, is $720. So that is your M. Okay, so this guy right here is $720. So they want to know how many years the nearest tenth will they be paying on their house. How many months is that? So on and so forth. And here's where the fun begins. So we're going to plug in now. We know what M is. They told us M was 720. So step 1, plug in. Step 2, cry a little bit. Step 3, continue working. The principal amount is $120,000. The rate is 0.048. And then we have to do 1 plus that to the power n. Come on. And it's all over, again, 1 plus the rate over 12 to the power n minus 1. So there are a few things that you want to do right off the bat. Anything that you can do, it's very basic, simple math, even if it's in the calculator, which a lot of this, most all of this will be. You need to do that. So first thing I'm going to do is I'm going to take care of what all this is, what all this is, and what all that is. Okay, I'm going to figure out what all those decimals are. So I have 720, come on. Okay, it's going to equal, now when I multiply 120 into all of this right here, I get 480. And then the decimal that I get when I figure out what 1 plus 0.048 over 12, which happens to be the exact same decimal for here, thank goodness, is 1.004. So I guess I could put parentheses around this. Again, both of these say 1.004, okay, to the power n. Alright, so this problem becomes nasty. Well, I have two n's in it. I'd only like to have one n because I'm trying to solve for n. So I'm going to solve this by cross-multiplying. So I'm going to put this bad boy over 1. I'm going to cross-multiply. And this is the weird part. When we cross-multiply, what we get. I'm going to expand this a little bit so I have some room here. Alright, so I get 720. Has to be multiplied by both parts. 720 is going to get multiplied by this guy right here and this guy. So I'm going to write that 720 parentheses 1.004 to the n minus 1. Okay. And it's going to equal the right side, which doesn't change, 480, 1.004 to the power n. So, again, like I said before, I have to multiply 720 by both things. Okay, I can't multiply 720 times the 1.004, and this is something a lot of people miss. They're not paying attention to it, but this has got an exponent, so I just write it next to it. So this becomes 720 times the 1.004 to the power n. That's a multiplication symbol. And then minus, well, 720 times 1, right? 720. Now, let me see if I can erase this real quick. I can. So if you notice on both sides, right here and right here, I have 720 groups of this nastiness, and here I have 480 groups of this same nastiness. So what I'd like to do is subtract them and bring them all to the same side. Okay? So if I had 4 groups of something, and on the other side I had 3 groups of something, I could subtract the 3 x's over. This is the same idea, except I'm doing it with some really, really ugly things right here. So I'm going to subtract. I need to undo that. Okay, so I need to subtract off the 480, 1.004 to the power n. So I'm going to subtract off the 480, 1.004 to the power n. And at the same time I do that, I'm going to add the 720 over, because I know that's supposed to be on this side over here, so plus 720. So now I get 720 is on the right, and when I do my 720 minus my 480, it's like 720 x's minus 480 x's, right? I'm going to end up with 240 of those same things. So I get 240 of the 1.004 to the power n's. Well, now it's a problem that we've seen before. We just need to solve. So we're going to divide by 240 on both sides. I now have 1.004 to the power n equals. I'm dropping the parentheses. There's no real need to have them anymore. It's going to equal 3. This is now a log question where I change it from exponential to logarithmic form. So again, log base 1.004. Base will stay the base. Okay, and then switch the other two. Or remember that a log always equals the exponent. Go to your calculator, type it in. This gives you n. N becomes 275.2. Well, hopefully that's not years, but let's pay attention and go back up to the question and see what it's talking about. N is the number of monthly payments, so this is months. Okay? Whereas the question also says how many years, right? How many months? How many years? So it's 275.2 months. We're going to divide that by 12. So divide that, come on. So 275.2 divided by 12 is going to give us a number of years, which works out to be 22.9 years. Okay, this you try problem is going to be extremely important that you actually try it. I'm going to pause the video in a couple seconds here and write all the answers, but you're not going to be able to do these questions if you don't actually try it. So please do so. Go ahead and pause the video now. Alright, so here's the correct answer. Tons of fun. Start off by plugging your 820, 120,000. Okay. Plug in all your decimals, 0.048 over 12. Okay, cross multiply. That gives you 820 multiplied by the bottom portion here. 480 multiplied by 1 stays the same. Multiply 820 in, so 820 times the first part, you just write them next to each other. 820 times the negative 1 gives you minus 820. Now we're going to subtract the 480 over. We're going to add the 820 to this side. That brings us to this part of the problem right here, I'm going to divide both parts by 340. And then we end up with this. I've reduced the fraction of what 820 over 340 is. Take the log of both sides. I'm sorry, not take the log of both sides. Change it from exponential to logarithmic form. So log, the base stays the base. Log always equals the exponent. So it's log base 1.004 of 41 over 17 equals n. Works out to be 220.5 months. Number of years, 18 years. Okay. That's that. Let's move on. Okay, next example. Another tons of fun question. Okay, assuming a liquid starts at a temperature of 200 and begins to cool in a room at a state temperature of 70 degrees Fahrenheit. After 5 minutes, the temperature of the liquid is 153. The equation that can be used, again, is given, and it's nasty, and they all involve T. Look at it, there's 4 of them that have a T in it, for crying out loud. That's just disgusting, and that's what you're going to see. They're going to give you a formula. It's going to be nasty. You have to read carefully. You may need to read it 10 times. You may need to read it more, and that's okay, as long as you figure out where things actually go. So let's start to go through it. Alright, so assume that a liquid starts at a temperature of 200. So temperature, that must be the initial temperature, is 200. Okay? So this guy right here, initial temperature is 200. That's our T sub 0. It says cool in a room that is the temperature of 70. So that's the temperature of the surrounding liquid, right? The temperature surrounding the liquid, so this is 70. That's the temperature of the room. After 5 minutes, so the time is 5, the liquid temperature after T minutes is 153. That is tons of fun. Not really. Okay, so it even says, use the given information to solve for the decay constant. So they're telling you in the first part of it, hey, you're going to solve for K. It's not a lot of fun, I'm sorry. It just isn't. There's no way around it. It is just a miserable question. So we're going to plug in our variables. Okay, the value of T, the temperature after a certain number of minutes, after the 5 minutes, is 153. So we start off with the 153 equals the temperature T of A, which is the temperature surrounding the liquid, we said was 70, plus T sub 0, which is the initial temperature of 200, minus T sub A, the temperature surrounding the liquid, e to the negative K times T, which we said is 5. Nobody really writes negative K5, so we'll switch that to negative 5K after we do some work. So, first things first, I'm going to subtract the 70 over and get 83. And I'm also going to do the 200 minus the 70 to get 130. And then I'm going to change it to negative 5K. Now this is a problem that you've solved before. Looks pretty familiar to you, or at least it should. We have to get it so that it's pretty much the base of the exponents alone, and then we're going to use changing it from Venn form, exponential form, to logarithmic. So we divide by 130. So we have 83 over 130 equals e to the negative 5k. And now we're going to change it to the log form. Log base e of the 83 over 130 is going to equal our negative 5k. Remember, the log always equals the exponent, the base stays the base, because a log is just an exponent. Anyways, type that in the calculator, divide by negative 5, and you end up with k. Now it says to go to the thousands, so that's 3 places after the decimal, so 0.090. And again, the part that I did skip is dividing both sides by negative 5, but you can type it in the calculator and divide by negative 5 and you're good to go. So that's the value of k. Here's the key word here. And there's a key word. It says then, using your constant. So using this value that you now have, determine how long it would take for the liquid to reach a temperature of 100 degrees Fahrenheit to the nearest minute. This is a nasty question because too many people, far too many people, don't understand what the heck it's talking about. It's saying using k. Now, here's the problem. I will see a ton of people take all of these values that you have up here, plug them in, and k. The problem is if you plug them all in, including the time is 5, you can't possibly find an answer because there isn't a missing variable. You do need to think about that. So let's plug back in with what we know and keep going. So plugging in, we want the temperature to reach 100. All right, reaching 100 is the temperature after t minutes, which is the t, the first part of the problem. So our new t value is now going to be 100. It was 153 before, but that was just so we could figure out what k was. So 100 equals the temperature surrounding the liquid. It doesn't appear to have changed. It's still 70. So we're still going to have the 200 minus 70. That didn't change. But what did change is that we're looking for t, and they've now given us k. Now it's supposed to be raised to the negative k, which is 0.090 times t. And again, this is a problem that you've solved before. It's a problem that we just solved before, part A. So we're going to subtract 70. We're going to subtract 200 minus the 70 to get the 130, and keep going. So subtract 70 to come up with 30. The 200 minus 170 here is 130. E to the negative 0.090 t. Dividing both sides by 130, we get this. Oops, 0.090 t. We're now going to change to logarithmic form. Finally said it right. Log base e of 30 over 130 equals negative 0.090 t. Okay, go to your calculator, type it in. When you're done this side, you're going to divide both sides by negative 0.090, and you'll have your answer. T works out to be 16.29, so that is t equals 16 minutes. So when the calculator says determine to the nearest minute, you're just rounding it, okay? And you're good to go. Okay, so the you-try question, again, extremely important. I'm going to go ahead and post the answers here in a second, and then I'll go through it real quick. But it is extremely important that you do this and not just skip it and then listen to me talk about it again. Okay, so here we go. Got to plug in. So the first value for t, the initial temperature, the temperature of the roast after t hours, they tell us is 125. So we plug in a 125. Our value for t of a, the temperature surrounding the roast, which is the temperature of the oven, even though they don't really say that. The oven is at 350. And we have to plug in the 40 is the starting temperature of the roast, minus the 350, the t sub a, which is the surrounding temperature, e to the negative 2k is what that becomes. So again, once you've done this and you've plugged it in, it now just becomes a, can I solve this type of problem that we made you practice in class a couple of days prior. So divide by negative 310, get that nice fraction there. Change it to logarithmic form from exponential, so log base e, the base stays the base, log always equals the exponent, so it equals negative 2k. Type in the calculator, get an answer. From there, answer the next question, but again, it's a matter of plugging in. So they're telling you now they want the roast to be done. It reaches 165 and it's finally done. So 165 is the ending temperature, T, okay, after a certain amount of time. 350 is still the temperature surrounding the roast, temperature of the oven. 40 minus 350 didn't change, but your negative 2k did change, okay? And then you just work backwards and solve. End up with t equals 3.2. Let's move on to the last problem, thank goodness. So, spend some time on geometric series now, just because it kind of makes sense where we're adding things, continuously using this formula as well. Just makes sense to throw this in here. So, this formula is given on the reference sheet. It is a geometric formula, which just means it's a sum formula for us. And let's get going. Alexa earns $33,000 in her first year of teaching and earns a 4% increase in each successive year. So write an equation to model the amount of money she'll be making each year. Well, every year kind of fits, all right? She has her amount, all right? This is a 4% per year, so it's once per period. She's increasing it. So that's going to be the formula. All right, here is your P, here is your rate. It's compounded once per year, okay? So this is the basic formula. That's going to be 1 plus R, or P times 1 plus R, I should say. So P times 1 plus R to the T. We're not compounding it at all, so in this case it's the 33,000. And that's 1 plus 0.04, so that would make 1.04 to the power T. That's how much she's making. Okay, we can figure that out, plug in however many years she's been there, and then we'll know how much she is making. Part B, use your equation to determine how much money she will make in her 15th year. So, that's not so bad. A equals, we're going to plug in assuming a 4% raise every year. Type that into the calculator, get yourself an answer. 59,431. Got to round it to the nearest penny because that just makes sense. Nearest cent, it says. So 0.14. So $59,431.14 is how much the person will be making. Well, now it says C, right? Write a geometric. Oh, you stink. Here we go, trying it again. Write a geometric series. Well, the geometric series is as simple as plugging in. A sub 1, okay, is your starting, your initial amount, okay? So in that formula up above that you can't see anymore because I've moved it, come on. There we go. All right, A sub 1 is our 33,000. So we're going to have A equals, I'm sorry, the sum equals 33,000 minus the 33,000 times R, right, the 1.04 to the power n, all over 1 minus the 1.04, the rate. And there we have it. That is the formula that will determine her total earnings over however many years we have. So the next problem, use this formula to find Alexa's total earnings for her first 15 years. It's as simple as plug it in. So notice part B, we found how much she was making in her 15th year. In part D, I just broke my stylus. That's fantastic. In part D, we want to add up all 15 years. Okay, so here we go. We're going to plug in. We have S. We have S, oh boy, of 15. It's the first 15 years. Is going to equal the 33,000 minus 33,000 times the 1.04 to the power of 15 all over 1 minus 1.04. Type it in the calculator, hit enter, and rounding to the nearest penny, you get $660,000, 778 and 39 cents. Seems like a lot of money. So again, I want to point out this question right here was saying how much money will she make in her 15th year, and this is the total earnings for 15 years, how much money in total, and that is a series. A series gets you the total over time, whereas the formulas that we've been writing, okay, this guy right here and this guy right here get us the amount for a specific year. So in her 15th year, she makes this much money, I apologize. Whereas this one is all of the first 15 years added up, makes her $660,000. That's it. One last thing, it's important to notice that the rate formula that we're used to using, 1 plus R, and I just caught it myself, typically is 1 plus R, that's the rate of increase, right? The amount you're going up or down. But in this particular problem, this is the total rate. So it could be, or it is in this particular problem, that R stands for 1.04, not just the 0.04. So you do want to be careful there and notice the difference between the two formulas. And again, in this formula right here, 4% increase, R is the 0.04. But in this problem, R has to be represented by 1.04. And that should do it.